Okay, so we've got a question here. Find the limit as x approaches a. So we're not given a value here, we're given a variable instead. So we're going to have to be a little bit careful here. Of cosh of x minus cosh of a divided by sinh of x minus sinh of a. So first things first, let's just plug in a where we see an x. So therefore we get cosh a minus cosh a. This is not dependent on x at all, so it just stays cosh of a. And then we divide that by sinh of x. So obviously we want to put in an a there. Sinh of a minus sinh of a. Not dependent on x, so it just stays the same. So obviously this gives us 0 over 0. So this is an undefined value. So we need to do more work here to find the limit of this function. So how do we do that? Well, when we've got a 0 over 0 situation, that's one of the rules met for using L'Hopital's rule. So let's just write that here, L'Hopital's rule. And what L'Hopital's rule requires is that, first of all, you can get a 0 over 0. You can also get infinity over infinity, but in this case we've got 0 over 0, and that this function, top and bottom, so we've got the limit as x approaches a of f of x divided by g of x. F of x and g of x these are both continuous and differentiable. Now, the cosh function and the sinh function, as we know, these functions are both continuous and differentiable. So we can move on to do the first stage of L'Hopital's rule. So what we can say now is that the limit as x approaches a equals f prime of x divided by g prime of x. So all we have to do now is take the derivative with respect to x of this function here. So now that's going to leave us with, so cosh of x, derivative of that, sinh of x. Bear in mind it wouldn't be, it's not going to be negative as it would with a normal sine. This is the hyperbolic sine, so the derivatives of sine and cosine are always positive. And cosh of a, well, a is not dependent on x at all, so this is just a constant, so that just disappears. Now we've got sinh of x, so the derivative of that is cosh of x. And as we have before, sinh of a is not dependent on x, so when we take the derivative with respect to x, treat this as a constant, the derivative of constant is 0, so that disappears. Okay, so now we can just plug in our value that we're looking for to find the limit for as x approaches a. So now we just put in an a where we see an x. So now we get sinh of a divided by cosh of a. And that will give us our answer. But we can do better than that. Obviously this is now the hyperbolic tangent. So it equals tanh of a. That is our answer.